Hello friends, welcome to Geeks for Geeks. Today we are going to learn best fit algorithm for memory management. What is best fit? Best fit allocates the process to a partition which is the smallest sufficient partition among the free available partitions. Problem statement: given block sizes and process size, we need to find which block is assigned to which process under best fit algorithm. For example, input will be like this, that is block sizes and process sizes. Your output should look like this, that is which block is assigned to which process. Now let's look at the implementation. First, input memory blocks and processes with sizes. Initialize all memory blocks as free. Start by picking each process and find the minimum block size that can be assigned to the current process. That is, we find the minimum of all the blocks that are greater than the process size. And if we found, then assign it to the current process. Otherwise, we'll move to the further processes. Now, let's look at an example. Given block sizes 100, 500, 200, 300, 600 and process sizes 212, 417, 112, 426. N is the number of processes, which is 4. M is the number of available blocks, which are 5. Let allocation be an array of size n equal 4 and initialize it with -1. When I equals 0, process size 0, that is 212. So best fit block size equal 300. So allocation of 0 equal 3, which is index of the block having space 300. Then block size 3 minus equal 212, that is 88. So now this block has space of 88. Now when I equal 1, process size 1 equal 417. Best fit block size would be 500. So allocation of 1 equals 1, which is index of the block having space 500. Now block size 1 minus equal 417, which is 83. Available block sizes are 100, 83, 200, 88 and 600. When I equals 2, process size 2 equals 112. So best fit block size equals 200. Allocation of 2 becomes 2, which is the index of the block having space 200. Then block size 2 minus equal 112, which is 88. Now when I equals 3, process size 3 equals 426. Best fit block size equals 600. Allocation of 3 becomes 4, which is the index of the block size having 600. Block size 4 minus equal 426, which is 174. Now this is the block available: 100, 83, 88, 88 to 174. At last, your allocation array will be like this: 3, 1, 2, 4, and the output should be like this. Is best fit really best? Although best fit minimizes the wasted space, it consumes a lot of processor time for searching the block which is close to required size. Also, best fit may perform poorer than other algorithms in some cases. For example, given block sizes 150, 350, process sizes 325, 125, 50, n number of processes, which is 4, m number of available blocks, which is 2, let allocation be an array of size n equal 4 and initialize it with -4. When I equals 0, process size 0 equal 300. Best fit block size would be 350. So allocation of 0 equals 1. Block size of 1 minus equal 300, which is 50. When I equals 1, process size 1 equals 25. So best fit block size equals 50. Allocation of 1 also becomes 1. Block size of 1 equal 50 minus 25, which is 25. Available block sizes are 150, 25. When I equals 2, process size of 2 equals 125. Best fit block size equal 150. So allocation of 2 equals 0. Block size of 0 equals 150 minus 125, which is 25. When I equals 3, process size 3 equals 50. Best fit block size is not available here, as you can see. So allocation of 3 equals minus 1. It remains minus 1. This is the allocation array 1, 1, 0, minus 1, and this is the output. Though 25k plus 25k equals 50k was available, still we were not able to allocate block to process number 4. This is known as external fragmentation. In first fit, this is the scenario. So process 4 gets allocated to block number 2. Therefore, in some cases, first fit may give better results. You may refer to the link provided in the description for first fit. Thank you for watching this video. I hope you like this. Please leave us your likes and comments.